Ever wondered what makes our modern world tick? From the phone in your hand to the systems that run our cities, it all comes down to one incredible invention: the computer. But what exactly is a computer? Let's break it down. At its core, a computer is an electronic device that processes data. Think of it as a super fast, super accurate brain. You give it some input, like typing on a keyboard or tapping on a screen. It then processes that input based on a set of instructions called a program and gives you an output, like showing a video or calculating a sum. Simple, right? But the magic is in how it does it. What makes computers so special? Let's talk about their key characteristics. First, speed. Computers can perform billions of calculations in a single second. Imagine trying to do that by hand. It would take a lifetime. This incredible speed is why we can stream movies, play complex games, and get instant search results. Next up is accuracy. As long as the data and instructions are correct, a computer will produce an error-free result every single time. It doesn't get tired or distracted like we do. This reliability is crucial in fields like science, medicine, and finance, where even a tiny mistake can have huge consequences. Then there's storage. Computers have a massive capacity for storing information. All your photos, documents, music, and videos can be saved and accessed whenever you need them. This ability to store and retrieve vast amounts of data has completely changed how we handle information, moving us from physical file cabinets to digital clouds. Computers are also incredibly diligent. They can work continuously for hours, days, or even years without a break, performing repetitive tasks perfectly every time. This is a huge advantage in manufacturing and automation, where consistency is key. And finally, versatility. A computer isn't just a one-trick pony. By simply changing the software or the program it's running, a single machine can be a word processor, a video editor, a music studio, and a gateway to the entire internet. This flexibility is what makes computers so powerful and so integrated into every aspect of our lives. So, where do we actually use computers? The answer is everywhere. In education, they've revolutionized learning with online courses, digital textbooks, and interactive simulations. Students can access a world of information from their desks, and teachers can create more engaging and personalized lessons. In the world of entertainment, computers are the magic behind your favorite movies' special effects, the immersive worlds of video games, and the platforms that let you listen to any song you can imagine. They've transformed how we create and consume media. Business and industry rely heavily on computers for everything from managing inventory and finances to designing products and communicating with a global workforce. They increase efficiency, reduce costs, and open up new opportunities for innovation. And let's not forget science and medicine. Computers help scientists analyze massive data sets to make groundbreaking discoveries, from mapping the human genome to modeling climate change. In hospitals, they assist in diagnosing diseases, monitoring patients, and even performing complex surgeries with robotic precision. Even our daily lives are filled with computers. Your smartphone, your smartwatch, your car's navigation system, the checkout scanner at the grocery store, they're all computers working to make our lives easier and more connected. The importance of computers in modern society simply cannot be overstated. They are the backbone of our information age. Now, not all computers are the same. They come in various shapes and sizes designed for different purposes. Let's explore the main types. First, we can classify computers based on how they process data. This gives us 3 categories: analog, digital, and hybrid. Analog computers work with continuous physical quantities, like voltage or pressure. Think of a traditional thermometer with mercury. As the temperature changes, the mercury moves smoothly up or down the tube. Analog computers are super fast but are less precise and have limited applications today. They were common in the early days of computing for specific scientific and industrial tasks. On the other hand, we have digital computers, which are what most of us use every day. These computers work with discrete values, represented by a series of ones and zeros, known as binary code. Your laptop, smartphone, and desktop are all digital computers. They are incredibly versatile, accurate, and can store huge amounts of information, which is why they dominate the modern world. And then there's the hybrid computer, which, as the name suggests, combines the best of both worlds. It has the speed of an analog computer and the accuracy and memory of a digital computer. You'll find these specialized machines in places like hospital intensive care units, where they monitor a patient's vital signs, which are analog signals, and convert them into digital data for analysis and display. Beyond this classification, we can also categorize computers by their size, power, and purpose. This is where we get into supercomputers, mainframes, and microcomputers. Let's start with the giants. Supercomputers. These are the most powerful, fastest, and most expensive computers on the planet. They are absolute beasts, capable of performing quadrillions of calculations per second. You won't find one of these at your local electronics store. They are used for highly complex and calculation-intensive tasks, such as weather forecasting, scientific research, quantum mechanics, and nuclear simulations. They are essential tools for solving some of the world's biggest challenges. Next in line are mainframe computers. While not as powerful as supercomputers, mainframes are still incredibly robust machines designed to process massive amounts of data for thousands of users simultaneously. Think of large corporations and government organizations, banks, airlines, and insurance companies. They use mainframes to handle critical applications like online transaction processing, census data, and enterprise resource planning. They are known for their high reliability, security, and uptime. Finally, we have the category that we are all most familiar with: microcomputers. This is a broad term that includes the computers we use every day. It all started with the invention of the microprocessor, a single chip that contains the entire central processing unit of a computer. This innovation made computers smaller, cheaper, and accessible to the general public. Within the microcomputer category, we have desktop computers. These are the traditional PCs you see in homes and offices, with a separate monitor, keyboard, and mouse. They offer a lot of power and are easily upgradable, making them popular for gaming, content creation, and professional work. We also have laptops or notebook computers, which are portable versions of desktops. They integrate the screen, keyboard, and a trackpad into a single unit powered by a rechargeable battery. They offer a great balance of performance and portability, allowing us to work or play from almost anywhere. And, of course, we have the computers that live in our pockets, smartphones and tablets. These handheld devices have become indispensable, packing an incredible amount of computing power into a tiny form factor. They are our personal communicators, navigators, cameras, and entertainment centers all rolled into one. So there you have it. From the basic definition of what a computer is to its incredible characteristics of speed and accuracy, its vital role in every part of our society, and the diverse range of types from massive supercomputers to the smartphone in your hand. Understanding these concepts helps us appreciate the technology that shapes our world and empowers us to use it more effectively. Thanks so much for watching. I hope you found this breakdown helpful. If you did, don't forget to hit that like button and subscribe for more tech explainers. Let me know in the comments what computer concept you'd like me to cover next. See you in the next video.